So in this lesson, we're talking about long division, and there is an activity that goes with it. It's called 4-7 long division, and we're specifically looking at dividing polynomials. Now, you've learned long division. That looks familiar. And what you had was some steps. I learned this as Dirty Marvin Smells Bad when I was in grade school. Dirty Marvin Smells Bad spells the acronym to remind me the steps to do. The first step was to divide. So 2 divided by 2 is 1. Or how many times does 2 go into 2? Really what you're doing is dividing in your head. So then our next step was to multiply. 1 times 2 is 2, and then we subtract. So when you subtract that, you get 0. And then you bring down the 5, and you start the whole process again. So 5 divided by 2 is 2, and there's a little remainder, and we never cared about that. 2 times 2 is 4, subtract, you get 1, bring down. 2 goes into 16 8 times, 8 times 2 is 16, remainder 0. Now right here, back in the old days, if you had had a number here, you would have said my remainder is whatever that number was over 2. Well, because this one came out even, there is no remainder. Okay? But remember how you did the remainders. You turned them into a fraction. You said remainder, whatever this sum was over your divisor of 2. Now also in grade school, you didn't stop right there if you had a remainder. Sometimes you had to add a decimal and a lot of zeros to figure out if this was a repeating or a terminating decimal. That's what made it so miserable to do long division. In these problems, when you are out of things to bring down, there's nothing left to bring down, you're done. We don't care about repeating or terminating anything. We will stop and write the remainder. So let's look at how one's going to work. And so in this one, we're going to divide 9x into this fourth degree trinomial. And I'm just looking at number 1. And so we're going to purposefully get a 0 every time we subtract. You've never been focused on that when you did long division. So whatever goes here needs to multiply to get 3x to the 4th. And eventually we will subtract it. We're not trying to get the negative 3x to the 4th. We're trying to get this term exactly so that when we do subtract, it goes away. This is hard to see because it involves a fraction. If you will remember fraction rules, you'll remember if you multiply a fraction by the denominator, they cancel, and you're left with the top number. That's exactly what I want. All right, now I'm trying to get to an x to the 4th. So remember when you have same bases, you add exponents. This is a 1, so what would I put with a 1 to get a 4, and that's a 3. Okay, so what needs to go into the red box is 3 over 9x cubed, which is the same as 1/3 x cubed, and we don't write the 1. So up top we're going to put x cubed over 9, and we know when we multiply that we get 3x to the 4th. So we subtract and we get a 0, and that's exactly what we were trying to do. Now after we divide and then multiply and subtract, we have to bring down. So we're going to bring down 27x cubed, and we're going to start this process again. What would I multiply times 9x to get 27x cubed? That's what you're asking yourself for this term, because I want it to multiply to give me that. That one's a little easier to see. It's a 3x squared. 3 times 9 is 27. X cubed times x is x squared times x is x cubed. And when you subtract, you get a 0. It's exactly what you want. And now you bring down 27x squared. start the process again. What you put here is what's going to multiply by the 9x to give you this 27x squared. Because remember, the green box times the divisor gives you that number that you end up subtracting. And I hope you can see that that is 3x. So 3x times 9x is definitely 27x squared. That's what you wanted. Subtract, and you have a remainder of 0. And that's done. So if you look at the answer choices on number 1, you can see that this is D. Now there's another way to look at that, especially when this first pair of terms requires a fraction, which is sometimes a challenge to figure out. When you're dividing by a monomial, and we've done this when we converted linear equations into slope-intercept form, and you had to divide by the coefficient of y. Remember, when you divided an expression, you had to divide every single piece. So this is equivalent to that. That becomes easier to see. 8's cancel. N over 4 with the n1 on the bottom leaves you with an n cubed on top. In the second term, your 8's cancel. 3 minus 1 is 2, so you have n squared. Over here, the 4 cancels, leaving you a 2 on the bottom. So it's something over 2. And 2 minus 1 is 1, so the n stays on the top because the 2 was the largest exponent. So you end up with n cubed plus n squared plus n over 2. And this was specifically number 3. And you can see if you look at your answer choices, that would be answer choice A. So I want to make a distinction here about what we're dividing. These two processes were when we had a divisor, or the thing outside the house was a monomial, or one term. We could use this process by dividing each piece by that monomial, and it was easier to see. But when you divide by a binomial, you have to use long division. Today, in the next lesson, I will show you a different way to divide this. So let's look at the problem, number 13. And we're going to divide x squared plus 14x plus 49 by this binomial of x plus 7. Okay, so when you're doing this with a binomial, notice there's a binomial as a divisor, what you care about are only the first terms. You do not care about the 7 right now. Just the x and the x squared. What would you multiply times x to get x squared? And that's going to be x. Okay, so now you multiply. So you're saying x times x plus 7, and that's a distributive, which gives you x squared plus 7x. And now we have to subtract. We're not just subtracting the first term, we're subtracting this entire quantity. So x squared minus x squared goes away. 14x minus 7x is a 7x. You cannot forget that you're subtracting the 7x too. Biggest mistake in long division. And now that we've subtracted, we go ahead and bring down. So plus 49. Now again, we're only looking at the first term. That's what we're trying to cancel out. And what would you multiply times x to give you 7x? That would be 7. Now we're going to multiply 7 times x plus 7, which is a distributive. And that's going to turn into 7x plus 49. And when you subtract that, you have a 0. And now you look, am I done bringing down? there's nothing left, that's how you know you're done in this long division. So your final answer is x plus 7. So if you look at your answer choices on number 13, which is the one that we did, the choice is B. But I want you to see some things here. This tells you that if you were to multiply those two numbers, you would get that trinomial. So x plus 7 times x plus 7 is definitely x squared plus 14x plus 49. And if you ever want to check your work, you can double check that multiplication and see if you end up with the trinomial you started with. Remember how we started this lesson. If you wanted to double check this, you would say 128 times 2, and your teachers made you do this. They said you got to double check your work. And what you did was you multiplied 128 by 2, and you were trying to make sure you got the dividend of 256, and that's how you double checked your work. Well, same thing here. If we take x plus 7 times x plus 7, that should equal x squared plus 14x plus 49. And we just did this in our last lesson. It's a double distributive or a FOIL. So the first term is x squared, outer 7x, inner 7x, last term's 49. And does that equal x squared plus 14x plus 49? And I think you can see that 7x plus 7x does give you 14, so you are correct. So that's how you do the long division with polynomials. The key was you only look at the first term every time. You kind of ignore this constant. Remember, this was binomials, so this, if you want to get some extra practice, you're going to look at long division of polynomials, and you could also look at dividing by a binomial. Now you're going to see information about synthetic division. Don't look at that yet. Ignore that. That's going to confuse you right now. You want to be sure you're only watching long division or looking at concentrate on those resources. Okay? All right, good luck.